Hey, good morning, everyone.
Good morning, Professor.
Hey, good morning,
Morning,
Jason.
Professor.
Good morning, Jordan. Well, I have a I have a little technical difficulty this morning, which is clearly not a good news. Actually, it happened yesterday. My computer crashed and it needs to be repaired. So I'm currently using my old computer, which is running on Windows 10. So this is a everything I had to download everything, and I'm still very limited. In a lot of things are limited because in the old with the old computer, it's not um, it's not touch screen, so I can't draw. I can draw with with the mouse, but there's a lot of limitations, and also
What, do you know
yeah,
exactly what the problem is?
yeah.
Okay,
Well,
okay. I wanted to make sure if you ever need any help.
yeah, I'll need to get the. I'll need to uh, take the. I'll need to repair the computer. Um,
Okay.
that's one thing, and I will. So everything is like temporary. What I have on my old computer, I didn't even have. Um, I didn't have a lot of things that I had on my um, the regular computer, which was running on Windows 11. I think this one is running on Windows 7. It says Windows 7. This is horrible. Um, I think I upgraded it to Windows 10, and then no Windows 10 is no longer supported, and it cannot be upgraded anymore to Windows 11. So I had to, um, and I've been using the that computer for at least more than 2 years. And going back to like a computer that I used to use, 3 years ago, everything is difficult. But anyway, at least I get I have no problem opening the blackboard and a lot of things. But anyway, until I get my until I fix my computer. I'll have, everything is very limited. I can't even retrieve, uh, I can't even recover the privileges I had on the PDF. So uh, it's very difficult. But anyway, let's see. But, life must go on. The class must go on. We have 13 people in the collaborate, and let's see if I can. Yeah, I should be able to share the application. There you go. Uh, let's see how many people are in the forum. All right. So I have, looks like I have 16 people in the forum, and 13 people. Yeah, 13 in the. Okay. So I had to. Oh, what happened to because the whiteboard is not supported on this computer. I can't even use whiteboard, so uh, I improvised. I got something, yeah, something called I don't know. This is German software, and everything is in German. In this, all the instruction is in German. Uh, I can use it like um whiteboard. So at least, so in our last class, where is oh yeah, eraser. Okay. Okay, so in our last class, we were, we were talking about multiple cash flow model, right? I'll just, use, abbreviation, multiple cash flow model. And as an example, back, I have to draw with the mouse, so please bear with me. In multiple cash flow model, the first example we looked at is kind of, irregular amount at sporadic interval, right? Making a deposit or making a payment. And deposit and payment are two sides of the same coin. If you are at the receiving end, that's the let's say you got a loan, and if you're paying back, but usually, if you get a loan from a bank or from an institutional lender, you will have to make payment in annuities. In other words, regular amount at regular interval. But let's say you borrowed money from a family member or from a friend. Usually, it's kind of uh, the payback term is kind of relaxed. I mean, it's kind of loose. Uh, Between very good friends, you pay back um, whenever you can, and then it turns out usually, that whenever you can would be indefinite. Um, but usually they pay back then, the large lump sum at the end, like in 2 years, or or they pay back little by little, but in irregular amount and at irregular interval, right? So that example, that case we saw in our last class. Also, you are making you can make a deposit, but at irregular interval, irregular amount and irregular interval. But then uh, the interest rate can change. You're making a deposit with no binding contract, so you just make a deposit whenever you want, whenever you can. So whatever amount you want. So then, it will be subject to interest rate changes. So that case we have, actually seen in the last class. Second case is annuity. Okay. Uh, and I also said something about annuity last time. Annuity sounds like a annual thing, but no, it's not just annual. It can be monthly, quarterly, but the point is, it's regular amount. Oh, regular, so slow. And at regular interval, right? Okay, how do I move this thing now? Okay, I don't know how to move this. Oh, it will be the next page. But then, okay. So instead of just you'll just need to use your good sense. That means regular amount at regular interval. Now, the annuity, as an example of annuity, let's take a look at this example, right? So here's the thing. Suppose you're making a $1,000 deposit at the end of every year for the next 5 years. Okay, so this is regular amount, $1,000, regular amount, and you're making that deposit at the end of each year, at the end. Yeah, you don't have any money now, but you work, and by the end of the year, you'll have something. You'll have $1,000 to save. I mean, after so you have disposable income of 1,000 that you want to save at the end of the year, 1,000, and at the end of the second year, another. So over 5 years, and if the interest rate is 20%. What will be the total future value of all these deposits? And it's not a difficult thing. We can easily find the future value of the first $1,000 deposit. First $1,000 deposit will earn interest 4 times, compounded, right? Because this 20% will be compounded 4 times. Second one will earn interest 3 times compounded. Third deposit will earn interest 2 times compounded. Fourth one will earn interest just 1 time. And the last one will not earn any interest because last one at the end of year 5, you just dip it. I mean, making a deposit here makes no sense because anyway, at the end of year 5, you will make the withdrawal. So this is like, as soon as you make the deposit, you withdraw. So there's no earning any interest. So it's and practically, you don't even need to even put the money in the bank because anyway, you're withdrawing the money, on the last day of year 5. And why would you, on the last day, why would you put the money in the bank? You don't have to put the money in the bank. I mean, anyway, it's not going to earn any interest at all. So without even putting the money in the bank, I mean, you will still have $1,000, right? So then, in that case, the future value of these annuities, right? So I use, they generally don't make any distinction between future value of annuity and just regular future value. The regular future value is single cash flow model, right? The future value in the single cash flow model. Single cash flow model. A single cash flow model will just have single cash flow model will just have one, single cash outflow and single cash inflow. In this case, there are multiple cash outflows, right? Multiple cash outflows. And then finally, there will be one single cash inflow, right? Does that make sense? So it's not difficult to find the future value of this. And I make the I distinguish between single cash flow model and annuity. So I would use, notation, FBA, for future value of annuities, right? And then in this example, we made deposits at the end of the year, right? But there can be another situation where we make the deposit at the beginning of each year, which would look like this. The picture at the bottom, right? The picture at the bottom has a little, different data, right? The deposit is not 1,000 but 5,000. Interest rate is not 20% but 10%, right? I couldn't find the matching picture, so I just used, this one. But you get the idea. I mean, still good enough to convey the concept, right? If you're making deposit at the beginning of the year, the first deposit will earn interest compounded 5 times, right? 5 times. Second deposit will earn interest 4 times, and so on. And even the last deposit will earn interest just once. So in other words, imagine a picture where you're making a deposit here, right, at time 0. And then in that case, there's nothing here. At time 5, there's nothing there. And then the first one will earn interest 5 times compounded. Second one, 4 times compounded, and so on. And the last one still earns interest once. Okay, so the difference between the two is the second case is called annuity due, right? First case is called ordinary annuity. The second case is called annuity due. So literally, it means the annuity deposit or annuity payment is due to begin with, right? It's already due to begin with. I'll tell you here, all right, the difference between the two models is just one more compounding. Think about it, it's just one more compounding, right? It's one more compounding. So let me use where is it? Oh, it's here. And that seems, yeah, but think about it. This example is rather simplistic, too simplistic. I mean, in reality, you can do it this way. You can do it like, finding future value of every $1,000 one by one, which is, just, single cash flow compounding, right? You can do it like this, and add them up. If we have a very simple model, like in this example, just 5 deposits, 5 years, 5 deposits, you can do that, right? But and each time the deposit or the payment is only 1,000. I've been telling you deposit and the payment are the same thing because they are two sides of the same coin. So if that's the case, but in reality, right? In reality, it won't be that simple. I mean, the timeline will be like, it's not going to be just 5 years. It can be like, 10 years, 20 years, 30 years. And think about it. This type of, what kind of, example will be a typical one for this type of example? Here's the, okay. Let me put you on hold. This is, I gotta take this call. It's from the department chair. So, yeah, hi, Mahat. Hello? Yeah, yeah, hi. Can you give me a second? I'll put the class on hold for, okay. I'll put the class on hold. There is, all right. All right, sorry about that. Today, we have departmental meeting, and so with my computer gone, my regular computer gone, so many things are chaotic. So many things are in a mess. And as I said, my old computer is because the apps that were installed in the my regular computer, it have to like you have to log in and you have to retrieve. A lot of softwares are supported through the CUNY, so I need to I have to remember what password I used. I mean, those things are, and through what channel, and I can't remember, all of them. So everything has to all start from the scratch now, and that's what makes this, more difficult. Anyway, at least I have my old computer. At least I don't, I didn't lose, I didn't lose connection with you guys. That's a good thing. So here, let's take a look at a more more realistic example. More realistic example is something like this. So let's say you are preparing for a graduate school in 5 years. Okay, you wanna, and you're planning to go to Baruch, not for bachelor's. I mean, bachelor's, let's say, done already. I mean, not done yet, but that's why after bachelor's you want to go for MBA, masters. So, and your timeline is 5 years. Let's say you are, freshman now, and if things go well as planned, uh, you will be able to graduate with bachelor's in 4 years, okay, or in 5 years, and then you make a smooth transition to graduate school. In your 4th year, you start, take the GRE or GMAT exam, apply for graduate school, and got admitted. Now, these days, in the old days, you could get into an MBA program right out of, bachelor's degree. But these days, good MBA programs require work experience, corporate work experience. So let's say if things go well, everything goes well, so you graduate with bachelor's degree in 4 years, and you land a job, a corporate job, and you work for 1 year. You have 1 year work experience, corporate work experience. So you get admitted to an MBA program in year 5. I mean, in year 6, that will be in year 6, which is, so then, your timeline is 5 years because, after graduation, work for 1 year, so 5 years. Or otherwise, let's say your, bachelor's took 5 years. So then next question is, how much does it cost? Well, prestigious schools, prestigious MBA programs will cost a lot. It will cost probably anywhere between 40K to 60K a year, right? If it is, like prestigious schools like Harvard, Princeton, MIT, Yale, Columbia, it would cost a lot. So you look for affordable school. That's why you pick, CUNY. Baruch Zicklin School. So let's say it will cost $30,000 a year. So it's $60,000 for 2 years. The next question is, how do you raise that capital? How do you raise that fund, right? How would you raise that fund? How would you raise $60,000? Well, you might think of, let's say, if you have about $40,000 now, then you can put it in a bank for 5 years, and if the interest rate is good, probably putting 40K in the bank for 5 years, it might grow into 60K. If the interest rate, we can easily calculate it, right? Remember, we can go back and here, let's figure out how much it should be. If your target future value is, what am I trying to do? 60K. I'll just change that to 6 and change this to 4. And assuming compounding is once a year, then it would still, be a decent, very, divide this by this. these two, 1 over, which is C18, which for 5 years, right? Minus 1. Minus 1. Yeah, then APR should be 8.5. APR should be 8.5, right?
It didn't round.
Hmm?
It didn't round it off to the nearest decimal.
Yeah, of course. Yeah, it's rounded off to. You can increase the decimal and see. It's like this, okay?
Right.
Just like this.
Okay.
But you don't need to use more than 2 to 3 decimal places, okay? But there's no point in, because anyway, in currency, right? We're using, I mean, do we use anything below cent? Huh? We don't use anything below cent,
Absolutely
right?
not. We don't.
Yeah, that's right. So, and also for that reason, we don't use, generally below, 2 decimal places, more than 2 decimal places. And also for even for interest rates, we can use up to three decimal places, right? Because just like 3 digits for every comma, right? 1,000 comma, and then another 3 zeros comma, and that's million, and another 3 zeros comma, and then that's billion, right? Just like that. For rates, maximum decimals we use 3. That would be enough, right? And beyond that, it's it's meaningless. I mean, it's not that meaningful. Why? Because 3 decimal places, that's already 1,000th. Isn't that right? 1,000th of a percentage point. So beyond 3 decimal places, 10,000th of a percent. How much would how much impact would it have, right? So usually, not more than 3 decimal places. It's of course rounded, right? Yeah, but then here's the problem. Um, then that is based on the assumption that you have 40K already, and also it's based on the assumption that the interest rate is like 8.5. I mean, in this day and age, where can you find 8.5% interest rate? Huh? What kind of bank pays? The bank will pay at best. If you put your money in the CD, so it's not realistic, right? The CD at best, it will pay like 1.5%. That will be, even very by today's standards, very high interest rate. So that's all very tall assumption, right? That's all very tall assumption. Also, who has $40,000 in their name? I mean, some of you may, but you're all students. You are, just about, in your early 20s. At most early 20s, for most of you, and for that age, when I was 20, 21, 22, I didn't have 40K in my in my name, in my bank account. Uh, uh, I remember I had about maximum I had was about $1,000 in those days. Um, but if you do, good for you. But then you have to find a lender, a borrower, uh, that will pay this interest rate. So that is quite unrealistic. But then the realistic scenario is then annuity, isn't it right? if you if you can make if you can save at least something like $800 every month, you have a 5-year timeline, 5-year timeline, and so there will be 5 times 12. There will be 60 deposits of $800 you can make, and $800. Suppose you have, let's say you have a part-time job, so you work part-time and you can save at least like $800 every month. Then, if that's possible, then let's see how it's going to work. I mean, think about it. The picture will look like this, but then instead of 5 on your timeline, there will be 60 notches, 60 notches on your timeline. Each notch is 1 month, right? Monthly. And realistically, the interest rate is very low, but let's use assumption that the APR is 6%. 6% APR is like historical average of interest rates for as long as the data we have data for as long as we have data of interest rate, and probably the data goes back to like probably at least like 18th century, but prior to that maybe we don't. There could be some written account, but in those days they didn't keep like meticulously kept data, because data keeping is a but we from the history we can tell, even in ancient times, ancient Roman, ancient Egyptian times, they still had the interest rate was generally around 6%. And why? Because it's like we all know, if we use monthly compounding, right? Suppose someone borrowed money, even in ancient Egyptian times or in Greek times, when they borrowed money, they paid interest, and the lender collected interest, right? Monthly. So think about it. If when they collected, interest at the end of the month, if it is 1% a month, then it will be 12% a year, and it was still considered very harsh, even by the standards of any era, ancient or modern. Yeah, 1% per month is that's 12% a year. So instead, half percent a month, right? 0.5% a month. Then annually it's going to be 6%, and then it looks like apparently even in ancient times, people generally consider that as reasonable, right? Reasonable. Somehow, even 6,000 years ago or now. So hence the historical average is about 6%. So assuming 6%, then this picture will look like there will be 60 of them, the timeline, and $800 every month, and it will be 800 times 1.005. So it will look like this. If I it makes it so hard. Was it here? Where was it? Yeah. So if we work it out like that, where's the pen? The pen disappeared. I don't know. Okay, now you can collect. How do you collect this? Okay, full. So then it will look like, the future value of all those annuities will look like the first $800. Let's call that payment. And it will earn interest 1 plus R 59 times. 59 times. You might wonder why 59 times. Of course, 59 times, because we are making a deposit at the end of every month. So here I need to now this is not really a good software to use because I can't drag it side to side or up and down. So keep in mind interest rate is 0.5%, not 5%. And then N is 60. Okay. That means N minus 1 is 59. And okay, let's see what I can. Undo that.
Plus 5 is 1.5.
Huh?
1.5 would be.
Oh, N minus 1?
Oh, and n minus 1 is 59. Then the
Yeah. So what was your question then?
so 1 minus rate, which is 5%, which is 0.5%.
Yeah, 0.5%. Yeah. Now, how do I move this? Ah, this is the. How I move this around? So then, I can't move this around. So I'll just have to keep writing. And then the second deposit will earn interest. Oh. Okay, the second deposit will earn, second $800 will earn interest. But you know what I'm talking about. 1 plus R raised to N minus 2. And then it will keep on going like this. And then finally, we will come to what the 59th deposit, right, which will earn interest once. And the last 60th deposit won't earn any interest, right? It's so hard to do it this way. But you get the idea. I mean, you know, I've explained this in the main lecture video. So let me I gotta have, you know, I will have to use, you know, I'll have to play the main lecture video. In the middle of the collaborate. Oh, it takes forever. Okay.
Oh, hi. How's everybody? This is the 59 times. That means then second deposit will be compounded. Dollars alone, there will be 6 deposits of $800. That's principal alone.
Oh, the whole time.
But just to make it $1,000 deposit will earn interest 4 times compounded. It's going to be this 1,000, and then 5 years ordinary annually, because right, the beginning of year 1, so time. If we had one elementary way of going of, so future value of annuity is like, think about it. First of all, the first deposit, right? Once again, payment is deposit, right?
Okay, that's pretty much. Okay,
raised to 0, right? You understand?
All right. So here you see basically the first deposit will earn interest t minus 1 times, or n minus 1. That capital T means, you know, terminal time, maturity, right? It keeps on going like this, and the 59th deposit will earn interest once, and the last deposit earns no interest. And as I said, the last deposit, I mean, technically it can be considered deposit, but it's like, you know, at the end of the last month of the last year, you just dip it into the bank and just take it out. So practically, you don't even have to make the deposit, but, you know, just to complete the terms of the contract, this, you know, annuity contract, you will need to present it to the bank anyway. But, you know, it earns no interest. But anyway, we can write it like this, because, you know, by now everyone understands that anything raised to 0 is 1. So if it is raised to, if it is 1, that becomes just PMT, right? Just becomes payment, right? And then
what that is, remember, anything raised to 0, it is what? 1. Isn't that right? Right? So if it is 1, now, however, this is if I didn't truncate it in the middle, what does that mean? I will have to write it all the way from t minus 1, 60 terms, you know, all the way from here to, you know, all 60 terms. Now, that's called a polynomial. Mathematically, polynomial means literally not many, right? Nomial means, you know, terms, right? That means, multiple terms, polynomial, right? So that is very tedious to write it this way. So we know better. Is there a better way we can do this? Yes, of course. We use summation sign, right? Summation notation, right? And so we're summing up all payment times 1 plus r raised to n, where n runs from 0 to t minus 1, terminal t minus 1, right? You get the idea of that?
All right. So far, can you hear my voice well? Can you hear it clearly?
Very clear.
Anyone?
Very clear.
It's clear, because I'm a bit concerned, because this is the voice from the audio from my video, and it is basically it comes out of my video, so it is from my computer, and I can hear it well, but I'm kind of telecasting it, I'm kind of broadcasting it through Blackboard, right? So in other words, the sound that is being played from my computer must be picked up by the speaker of the microphone of my computer, and it will have to be rebroadcast to you. So sometimes sometimes the sound quality gets severely compromised, because it's from an audio source in a video, and then picked up by the microphone, and then rebroadcast to you. So the sound quality gets compromised. But if you have any difficulty, so let me know. Did you have any difficulty listening to it? Did it sound clear enough?
I have a little difficulty listening.
Oh, okay. How about anybody else? Is it like, so it wasn't clear?
I hear it, though it's just a bit low, but I can understand what it's saying.
Okay, good. Bear with me, because I would like to write this on I don't have any whiteboard on this computer. I mean, this is an old computer. Whiteboard is not supported on this computer, and it's not a touch screen. I can't do. Also, what I'm demonstrating in this video, is still not with the touch screen, so it was very difficult. Anyway, yeah, I believe the sound quality is compromised, as I said, because it is from the video, and then picked up by the microphone of the computer, and then rebroadcast. So, but bear with me, until I get my computer fixed. All right.
This is a very nice way of making that long polynomial very compact, right? It's a nice way of expressing in a very long polynomial, repeating, right, recurring terms in a very compact way, right? So think about it. When n is 0, that's this, right? It becomes this. When n is 1, it becomes this, right? Because n runs from 0 to t minus 1, and you are summing them. When n is 2, it becomes this, right? When n is t minus 2, in this case, 60 minus 2, so 58, it becomes this. When n is t minus 1, it becomes this, right? When n is 59. So you're summing up all of them. Now, so that's nice, right? In other words, it's going to be, this is going to be $800, and this interest rate, if the interest rate is annual rate is 6%, we know what this is going to be. It's going to be 0.5%, right? It's going to be, so then our next question is, oh, that's wonderful, that's nice. We can nicely capture it in a very compact expression. But then, does it really help us actually calculate our future value? That's another question. Why? Because if you actually plug in the number here, right, $800 times 1.05 raised to 0 raised to 1. I mean, when it is 0, it's just $800, right? But that means you need to run this all over again. You have to actually do this all over again. This is, in other words, then what does that mean? Now, this is only a nice way of compressing, right, in a succinct, expressing this in a succinct way. It just doesn't, but it doesn't really help us to calculate, right? Understand? So then, how do we calculate it? So we have to use the reduced form, which is basically payment times, right, one plus r raised to n minus 1, okay, over r, right? Now that's the formula we need to use, and this is reduced. I mean, this formula doesn't just drop from the sky. It just doesn't pop up from the thin air, right? There are steps of derivation. This formula is derived basically from this, and there are steps of derivations. I will not show you at this time because it will take a lot of time to. It will take about 10-15 minutes, but we're going to get to that later. But right now, we want to use this formula to actually solve our graduate school fund question.
Okay, so this is basically, without showing you full steps of derivation that takes you from this long form to this, reduced form, right? I just, needed to introduce these concept before introducing the formula for future value of annuity. So we will, it's 12 o'clock, all right, 12:02. So it's about time to take a break. So let's take a 10-minute break and reconvene at 12:12. Okay? All righty, so 10-minute break.
Hello, Professor. I can't hear you. I'm gonna have to boot
Hi,
on.
Jason. Hi, Jason. I'm sorry. I was writing email and 10 minutes passed.
Yeah,
My
I'm sorry
questions.
I'm sorry to interrupt you.
That's okay. I mean, it's already well past time flies. I was writing email. Can you let me just uh,
Take your
can
time,
you let
Professor.
me?
This is
Yeah,
more
yeah.
important.
In the meantime, let me um, please listen to the rest of it. Okay, please listen to the rest of it.
Understand? Okay. So let me switch back to an Excel file. Okay. Okay. So let's see. Okay. Do you see this Excel file? Okay. Now this is, of course, this is the file we've been working on previously. We were on single cash flow model, right? This is the time value of money, right? And previously we were on single flow. Now we are on.
Okay. It seems like since I'm sharing my screen, it doesn't. It's not going to do any good because. Sorry about that. It's not going to do any good because as long as I'm using, writing, on the email, that's going to be what's going to be projected on your screen, on your monitor. All right. So that's this. Remember, you have this file. You already have this file downloaded, right? You have this file downloaded. So please open it and go to the bottom tab that says multiple cash flow. Okay. Go to the bottom tab that says multiple cash flow. Are you all there? And if you're there, you'll need to delete all the highlighted cells. Delete all the highlighted cells. Okay. Did you do that? Delete all the highlighted cells. How many people are? Let's see. I still have like 13 people. Jason is obviously there. Alisa, are you there, Alisa? Alisa. Cora, are you there?
Yes,
Cora.
Professor.
Okay, Cora, do you have this file in front of you? Do you have this file in front of you?
Time value.
This is nothing new. This is what we worked on this file in the previous class, right? So you must have it. You must, download it already, and you just need to go to the bottom tab that says single cash flow. Okay, and then you delete all the highlighted cells. Okay, everyone? Are you there, everyone?
Yes.
Okay, good. And
Sorry about
Felicia.
my computer is updating right now.
Mm-hmm. Felicia, are you there? Felicia. Grayson, I'll have to assume Felicia is not. Grayson, are you there? Grayson? Yeah, Kenny Lowe. Okay, Kenny Lowe, you're there. You're preemptive, right? You have taken a preemptive step to So Kenny, do you have that file in front of you, Kenny? Okay, good. Jordan, do you have that file in front of you, Jordan?
Yeah, I do, Professor. I have it right here.
Okay, great. And Jesus, you have that file in front of you, Jesus? Are you there, Jesus? Jared, are you there, Jared?
Yeah, do you want us to delete the green ones too, or just the
Yeah,
yellow?
I'm here.
Yeah. All the highlighted cells, regardless, all the
Okay.
highlighted cells. Okay? And then Michelle, are you there, Michelle?
I'm here.
Okay, do you have that file in front of you?
Yep, I have it in front.
Okay, great. Natasha, do you have that file in front of you, Natasha?
Yes, I have it, Professor.
Okay, good. Uh, I wish there was something like, thumbs up, like, like in the, okay, Jesus, do you have that file in front of you? Hmm. There are limited emoticons on Blackboard, and not even limited. There's nothing. Novia, do you have that file in front of you, Novia?
Yeah, Professor.
Okay, so you deleted all the highlighted cells, right? Okay, if you have highlighted all those, you know, cells, then let's do this. So we have our scenario is that you are trying to raise funds, right? You're trying to raise funds to um, to finance your graduate school, and that's going to be in 5 years, right? And you will do it. You will you want to raise 60K by making $800 savings. Making deposits $800 just by saving $800 every month at the end of the month. So APR is 6%. So row two, let's go to row two. APR is 6%, 5 years. M is 12 because it's monthly. Then periodic rate. The periodic rate is 0.5%. We already know because it's 6% divided by D2, 0.5%. And N is 60, right? Because it's 5 years times 12 months. Then, using the formula, and the formula is what? This is the formula, right? So we do exactly, future value of annuity, payment times, open parenthesis, 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 1 plus R raised to N and minus 1, but then we will have to include everything. Have to include everything in the otherwise Excel won't, no, computers won't, unless you do this, it's always PEMDAS. If there is nothing like that, if there is no, think about it, if there is no parenthesis outside, then it will simply be, it will simply do A2 times this thing first, and then raise that to F2 and subtract 1 from that. So that's going to be, a totally different thing. So, and then we divide it by R, right? And then hit enter. Oh, then what do you see? It's 55,816. So that means we're still short, right? I mean, we have our target future value is 60K. So we're still about, $4,000. We're still about $4,000 short, 4,000. And what's in here? We'll delete that, please. We'll talk about that later. So because your target future value is 60K, and we're still about $4,000 short. So what should we do? Well, then we can have a couple of other options. One, if possible, we increase our monthly savings to 850, right? And everything is the same, so we'll just we'll just copy and drag it down for the remaining examples. Another possibility is you find a bank that pays better interest rate, and 7% is obviously better than 6%. Maybe we can try 8%. Right? Usually, you won't be between the banks. Banking is a very competitive industry. Between the banks, the interest they offer cannot that be significantly different. It cannot be that drastically different. It will be just about the same, or not much difference. But let's say some bank gives us 8%. Another scenario is, well, why 5 years? We can extend it to 6 years. I mean, you can extend the timeline to 6 years. It will take more time, but you'll go to graduate school with more money. Now, under these different scenarios, right? Slightly tweaked scenarios. Let's see if we are going to reach our target future value. We don't need to do. First, did you get this? Did everyone get this? Did everyone get the same result for future value of annuity?
Yes, Professor.
Okay, then we'll just copy and drag it down. We'll copy and drag it down, and voila. And what do you see? If we increase our monthly savings by $50, we're still short. We're about $700 short. But and 8%, we find a bank that is that pays 8%. We're still about $1,300 short. But if we extend it to 6 years, the timeline to 6 years, we can more than enough. We can more than enough cover. We have more than enough to cover, right? We can more than cover the tuition, and so yeah. Then the question is, you can pick. You might increase this just a little until you find the future value to be 60K. But then again, this is called trial and error method. I mean, you try out different numbers, different inputs, until you find the desired or the target outcome. But then this is not a very scientific method, right? Making plugging in different numbers, that's clearly not a. We can, on the other hand, we can exactly nail down the payment. Okay, we're gonna talk about that in the next class. But since we are here, let me. This is the formula, right? Isn't that? This is the formula for. This is the formula for future value of annuity, right? And then I've been telling you over and over, you can solve for anything as long as you can identify the z equals x times y structure, right? I tell you, z equals x times y structure. So then, if you think about it, this formula is already presented in the structure. It's only takes only the sharp I. It's a matter of using your sharp eye to identify that, to detect that structure. So if you found it, then this is like Z, right? FVA is like Z, payment is like X, and the rest of it is like Y. It's exactly payment times the whole thing. You might wonder, is it payment over R? No. Hey, it's a product. Product can be in any form, right? I mean, it's whether when you multiply something to a fraction, anyway, it gets multiplied to the numerator. So it looks like this is part of the numerator. No, this is an independent term. It just gets multiplied to the numerator. So
so the equation right there, one open parentheses 1 plus r n power minus 1 over r will give you the example for y.
Yeah, that's the y. So then next question is, we wanted to nail the exact payment. We wanted to know exactly what should be the payment. Then in that case, we can solve this equation for payment, can't we? We can solve this equation for payment. Isn't it right? Because it's already z equals x times y format. Then solving for this for x, it should be z divided by y. So z divided by y, z divided by this, y. So dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction, right? So here, payment equals FVA, which is z, times the reciprocal of the thing in the bracket. And the thing in the bracket, I just wrote it like this because it's annoying and cumbersome to write every time. The thing in the bracket is this, 1 plus r raised to n minus 1 over r. The reciprocal will be right, r over 1 plus r raised to n minus 1. That way, we can exactly nail the payment, right? So everyone understands, the very basic, this is very basic math. When you divide something by, if you divide something by a fraction, it's the same thing as multiplying by the reciprocal of it. Isn't it right? Mm-hmm. That's why we were...
Yes, Professor.
Right. That's why we were able to use, x to the negative 1. What is x to the negative 1? It's 1 over x, right? When you multiply something, by x to the negative 1, it's actually dividing something by x because it's something times 1 over x, right? So our next exercise will be then, how do we nail the exact payment? But before we do that, let's think about this. This is what? This is future value of annuity due. And remember what future value of annuity due is, right? This is the annuity due, right? When you make the deposit or payment at the beginning of each period. Ordinary annuity is when you're making deposit or payment at the end, right, of each period. But annuity due is making deposit or payment at the beginning of each period. So, and I told you, right, in case the difference between annuity due and ordinary annuity is just one more compounding, right? It's just one more compounding. Right? One more compounding means, this is ordinary annuity, right? You just do one more compounding. In other words, just another 1 plus r. That means as long as we have this, right, we can recycle the result of ordinary annuity, isn't it right? We can recycle. In other words, so here we have the future value of ordinary annuity. We have ordinary annuity. Then that result can be recycled and just be compounded just one more time. Right? And compounded just one more time. And then that's your ordinary annuity due. And you drag it down. We find all annuity dues. Okay? So then, finally, this will be our last example. Then, to nail exactly, to arrive at exactly 60K, what should be our monthly saving, our monthly deposit, right? So that's our, final question. So we will nail exactly the payment. And since we already know, the payment will be, we can solve that for payment. So what do we do? Well, all we need to do is future value times R, or I haven't filled it out, but I'll fill it out later. Divided by, open parenthesis, 1 plus R raised to n minus 1, close parenthesis. And enter. Of course, nothing will be there because there's nothing here. But then once, oops, what did I do? Then I divide that by 12 and multiply this by this. Enter. There you go. I got that. Nailed it. Right? 859.97. In other words, yeah, we were very close. Isn't it right? When we were very close, right? When we tweaked them all, when we tweaked the assumption a little and assumed that we are saving $850 every month, then we were very close, only $700 short. So it wasn't that much different, just almost $10 more, right? $859.97 every month will take you exactly to 60K. Okay, so up to now, everyone is good. Did everyone get the same result, right? For ordinary annuity and annuity due, everyone got the same result. And also for payment, everyone got the same result?
Yeah.
Okay. Good. If you got the same result, then that's it for today. I will see you. Have a great afternoon, and I will see you guys. That will be next Monday. Hopefully by next Monday I will have my regular computer all fixed. Alrighty, I'll see you guys. Take care, everyone, and I will have to stop sharing. I'll have to call it a day. Stop recording and sign out. Okay? Have a great afternoon, everyone.
Thank you, Professor. You too.
You too.
All right. You too. Take care, everyone. Natasha and everyone.